Okay, let's test this real quick. All right. So the title of my presentation is JETS, the Ruby Serverless Framework. It's a tool I wrote basically just for fun, kind of. I wanted to use Ruby, something that felt like a little bit like Rails and AWS, so this was the end result of that. So we kind of cover how that works today. And already the MC did a great job introducing me, so it's going to be a little bit repetitive now. But this is the traditional background slide about who I am, my name, what I do, all those fun things. My name is Tung Nguyen. I run a DevOps consultancy called BullOps. It's mainly software on AWS and DevOps tooling on AWS. A lot of DevOps tools actually I built are written in Ruby. For my work in the space, I was pretty honored to be recognized as a AWS Container Hero. It was a quite big honor for me last year because there's only 5 of us in the world. I think it's for that tool I wrote called UFO there. That's a tool that helps kind of deploy Docker containers onto ECS. I have a bunch of other tools in the space like that Low Node CloudFormation template and another one called Jack and the Elastic Beanstalk for Elastic Beanstalk kind of deployments. But today, we'll talk about JETS, this Ruby serverless framework that I wrote. Okay, so I think the reason why we're here is last year, November, at reInvent, I took this picture. AWS announced official Ruby support for their AWS runtime, for AWS Lambda, Ruby as a runtime there. And before then, Ruby was a second-class citizen. There were a bunch of other languages supported, Node, Python, Go, and even C#, but no Ruby support. So that was, I felt like it just took them a long time to do this. And finally, when they announced it, I took this picture, I kind of screamed. I was like, yeah, I was so happy. For me, it was like an early Christmas present, the way kind of Ruby's released every single December. So I think this is a big deal because it puts Ruby as a first-class citizen in the serverless world. Okay? And I thought a good way to kind of explain and cover what Ruby serverless framework does is maybe cover some essentials in the serverless world because the world is relatively new to folks kind of not involved here. So let's kind of cover the AWS compute offerings currently in this diagram here. The one on the left side is EC2 instance. That's essentially a virtual machine. So you can spin those up pretty cool in like 2 or 3 minutes, and then you have full control of the operating system and full control of how you want to manage that server, right? So that's the nice thing about that. You have full control and customization of the server, but you manage it yourself. Then you go from left to kind of right here. ECS, that stands for Elastic Container Services. And what that is, the easiest way to describe that is a very easy way to run Docker containers on EC2 or their Fargate offering. But it's basically an AWS managed service that allows you to run Docker containers onto EC2. And then if you go to the right there, that's the more managed offering. That's Lambda, AWS Lambda. So what is AWS Lambda? Okay, so I put this in quotes with a smiley face because people call it serverless. And this is actually a really funny name because in order to be serverless, you need servers. So the name is really much oxymoron. It doesn't really make sense. But the term generates some buzz. I think it started trending and the hype kind of took on a war of its own. So that's what people call it now, serverless. So a way to explain what serverless is in AWS Lambda is serverless is basically just a way to run code without you managing that server, right? And a better way to describe this, I think, is it's essentially functions as a service. So you don't worry about the server here. This is completely managed for you. All you do is focus on your code. And you give to AWS and you tell AWS, you figure out how to run and execute my code. I don't want to think about that. I want to focus on my code, right? So the benefits of AWS Lambda, the serverless technology, there are a couple. Here are the ones that I want to kind of cover here. The first one is obvious, is the maintenance one. You don't manage that server. You don't have to worry about security updates. You don't have to worry about patching that OS. You don't have to maybe upgrade instance types, all these things. Instead, there's a team of AWS engineers, maybe hundreds, maybe thousands of guys, who this is their full-time job, right? You focus on the code. So that's a pretty big benefit there. The other benefit, I think, is the ability to continuously scale. So with EC2, there's something called auto-scaling, which is a pretty awesome feature when I first discovered it. You can configure basically kind of thresholds to scale up and down your EC2 fleet. So you can scale it horizontally out and then inward. But with auto-scaling, even though that's an impressive feat of engineering, you still have to configure your auto-scaling rules. You still have to set that up. With AWS Lambda, you don't do anything. It just continuously scales. All right, so that's a pretty amazing feat of engineering, I think. And then the last one is pay per request. The model that AWS Lambda uses is basically they charge you on per request and time basis. So the reason this is interesting, because if you could fit within their free tier, which is 1 million requests per month, you essentially get environments for free. So let's say you want a couple additional stage environments. On EC2 instance, you still have to kind of pay a regular fee there. With serverless, you can actually basically run it for free. So that's the benefits, but I wanted to address some of the serverless hype. There is a lot. I mean, the term itself is a little hypey, right? So let's talk about what I'm going to call AWS Lambda considerations. The first one is RAM. Okay, so with AWS Lambda, you're allowed to allocate up to 3 gigabytes of RAM and as low as 128 megabytes of RAM. Now, in the Ruby world, let's say you're running a server, web server, Puma, Passenger, Unicorn, whatever. What you do is you configure a number of processes and a number of threads, right? And usually a typical Rails application is about 500 megs of RAM footprint. So let's say you have like 6 threads or 6 processes configured. 500 megs times 6 is about 3 gigs, right? But in the AWS Lambda world, you don't configure the server. You configure the process. So you're scaling the entire process itself. This is the thing, this is the scale unit. Because of that, you're not really kind of limited by 500 megabytes. You're limited by 300 megabytes here. So if your Rails application, your process, your Ruby process is consuming 3 gigabytes of RAM, you probably have other problems. So I don't really think RAM is a consideration there. And then CPU is the other thing that people kind of think about, like, is your application CPU bottleneck? With most Ruby processes, at least in my findings, it's usually RAM. And the way CPU works in the AWS Lambda world is your CPU is allocated proportionally according to how much RAM you allocate the function. And the magic number is around 1.5 gigabytes of RAM. Then you get dual CPUs, you get 2 CPU cores. And most applications, I would say, unless you're doing maybe Bitcoin mining or HPC, high performance computing, you're going to be kind of fine in the CPU world, I think. So I don't think that's actually a major issue either. Network speed. Now, I think a lot of maybe engineers sometimes will say, oh, maybe I saturated the network, right? That's why my application is slow. Usually your application code. Usually it's RAM bottleneck or something that you could kind of tune. Like what you have here is basically the internet pipe within the AWS data centers. If that pipe is slow, other customers are going to complain rather quickly. And I've tested this even on the smaller instance types, and it's pretty fast. So I don't think that's a major concern either. Okay, max timeout. Lambda functions can execute to a max of 15 minutes. And this could be a concern if you're running long running jobs here. Then you have to save state and continue. So that could be a concern. But if you say you're serving web requests, I don't think a user can wait for your web page for 15 minutes to load. They're gone already, right? So generally, don't think that's too big of a concern. I would say that I actually think this is actually a concern, code size limit. So within the Lambda world, remember you're in their world. They're managing the servers, right? So you have a total of 256 megs that you can allocate to your application code as well as gem library dependencies. And some Ruby applications can take 100 megs of gem dependencies themselves, so that means you only have 150 megs left. So I think if your application is more than 250 megs, probably AWS Lambda is not a good fit for the application here. But I think about 2 years ago, the limit was 50 megs. Now the limit, they increased it about 2 years ago to 250 megs. I think they're going to kind of raise this over time. Okay, the last consideration I want to talk about here is cold starts. So when I go on Hacker News or Reddit, I hear a lot of people complaining and making a lot of noise about cold starts. So cold start, what is that problem in the serverless AWS Lambda world? Essentially, when the first request comes in AWS Lambda, it's called cold start. It's they spin up what's kind of like a container for the very first time. And there's some overhead associated with that. Now, if you're being really, really cheap with your RAM allocation, that overhead's like 1 second to 1.5 seconds. So there's some substantial overhead there. If you are not being like unreasonably cheap about your RAM allocation, like at least a gigabyte of RAM, then I've seen the overhead about 500 milliseconds. And then additional requests after that is usually in tens of milliseconds range. So that's what people complain about. And it reminds me of something in Rails called Russian doll catching. And Russian doll catching, what it is you have all these kind of fragments you catch, and you have a dynamic cache key, usually tied to an updated at timestamp. And whatever the updated timestamp changes, what happens is that cache is now is going to be fresh. So it's going to take some time because that request is probably hit database calls. It takes some time to generate it, right? But nobody kind of like cares about that because it's one request out of many, right? Unless you're building NASA spaceships, it's okay. However, people still complain about, so there's a workaround. So that's not an engine on fire. That's supposed to represent something called pre-warming of your Lambda functions. I have a better diagram. So here's a pattern that people use in the serverless world to keep your Lambda functions kind of pre-warm. You have a Lambda fork function that basically fans out and calls your other Lambda functions and sends a dummy payload. That dummy payload essentially will make sure that Lambda container is kind of warmed up, okay? And this is actually configurable and completely built into this Jets framework here, which I'll talk about a little bit later. Okay, so I cover AWS Lambda, but there's more to serverless than just AWS Lambda. There's something called API Gateway. So what is API Gateway? You could think about API Gateway as essentially a front door to your application. A user request comes in, API Gateway routes that to maybe a Lambda function, and that returns back to API Gateway. Another way you can think about API Gateway is you can think about it as a RESTful API. It's a front door, right? So user request could come in, you could hit a resource or a URL path there, and then HTTP verb, get, post, put, delete, whatever, and then that gets forwarded or routed to a Lambda function that comes back. So one way to think about API Gateway is routes as a service. Okay, there's even yet more to serverless. There's something called CloudWatch. And maybe some of you guys might be familiar with CloudWatch, maybe for the centralized logging aspect of it. But there is a feature built into CloudWatch called schedule event rules. So what schedule event rules is basically a way to repeatedly call a Lambda function periodically. So it's essentially a scheduler. It's like a clock, right? Except it's managed for you. You don't have to run a Heroku clock process or a scheduler process, whatever you want to call it. You don't have to have worker tiers because this is all kind of managed for you, okay? So there's the serverless component essentials review. We have Lambda, which is functions as a service. We have API Gateway, which is routes as a service. And we have CloudWatch event rules, which is our schedule events, which is a scheduler as a service. If you take all these components, combine them together, we can build this architecture, a traditional web API architecture, except this is all serverless components. The user request comes in, it hits API Gateway, a RESTful route, RESTful API, it hits a bunch of Lambda functions. Those Lambda functions now can talk to the backend storage. There's two backend storages kind of pictured in this diagram. There's DynamoDB, which is a managed database, is a NoSQL service database. It scales up and down depending on the request and throughput on demand. There's also RDS Aurora. That's a relational serverless offering from AWS also. That also scales up and down according to throughput and demand. You don't manage it, it scales it up and down automatically. And then at the very bottom of this diagram, there's the CloudWatch event rules, which is a scheduler as a service, and that's calling a hard job. It's a digging. Okay, so let's actually go into some typical service code now, and I thought another good way to kind of explain this to everyone is maybe just go through the console. So the console refers to basically the web browser. This is the AWS Lambda console. You go click create function. It's pretty easy. You do this all in the browser. You specify your function name and your Ruby runtime, and then you click create function. Then that gives you an IDE here, an editor. This is all in the browser, guys. And then I wanted to point out here that the handler, there's two parts to it. The part before the period is the Lambda function. That is actually the file name, so it's Lambda function.rb. And the thing to the right of the period is Lambda handler. That's the Ruby method that's within the file that gets invoked. And you can see what a Lambda function looks like. It has this signature. It has two keyword arguments, event and context. And in this case, it's just returning a hash structure with status code and body. So from there, you can hit the test button, and then you can test actually in the browser. And it returns results in the browser. So literally, it only takes actually a couple minutes to go on serverless. You could do this all actually in the browser like that. It's actually pretty easy to use. It's kind of insane. You can actually do everything and change all your code across all your containers with the browser. Okay, and then the next thing I want to cover is API Gateway. So how are we going to do that? We're going to use the API Gateway console. We're going to use the browser again. So you choose the protocol, you choose REST, you choose a new API, then you give it API name, you click Create API. Here, you can set up your RESTful resources. I'm setting up the home URL here, so that's the path or the resource, that's the slash, and then HTTP verb of get. I associate number 2 with a Lambda function, then I start typing on number 3, hello, and this kind of like an auto-completes when you're kind of doing this. You click number 4, save. That takes you to, and then it gives you kind of this feedback where it shows you this actually nice diagram showing the request coming in, hitting the Lambda function, and coming back out to the user. It just kind of shows it to you visually. Now lastly, CloudWatch schedule events. It's kind of hitting under events rules here, number 1. You click schedule, and then you can specify your fixed rate, 5 minutes to run this Lambda function repeatedly. Then you specify your Lambda function target, and does also, I think, autocompletes. You configure details. There's a confirmation page, and then finally the show page where it says a fixed rate of 5 minutes, repeatedly call this Lambda function. So there we go. We just did a crash course in serverless components, okay? We just cover Lambda, functions as a service, API gateway, routes as a service, and CloudWatch, a scheduler as a service, all managed for you. Okay, so most people, when they deploy serverless applications, they actually don't go in the console, in the browser, and code, and then save it, and then deploy and pray that works. That's kind of an insane way to do things. Instead, they use something which is, this is actually the way they're currently doing it. They're writing AWS Lambda functions as YML. I just want to emphasize, YML is configuration, not code. It makes me a little bit sad, but this is actually how most people are kind of doing it nowadays. It reminds me of the Java world. In the 1990s, I heard there was a lot of frameworks like Struts and Spring, and what happened was your job as a Java coder became this adventure of figuring out the XML configuration you have to modify. You knew that you have to change some type of XML configuration, and that would generate some type of Java code somewhere, and then you would pray that things would work. So this is kind of, I feel like it's kind of like similar, kind of. So that's one of the reasons I wrote Jets. So let's finally jump into some Jets code and see what Jets code looks like, right? Okay, so this is a Jets simple function. You define under the apps functions folder, and it just looks like an ordinary kind of Ruby Lambda function. There's actually not much value to this, but it's possible to do. But there's actually a lot more value with the other constructs I'm about to show you. So this is actually what Jets code kind of looks like. Here's the Jets controller. So the Jets controller, this is post controller, inherits from application controller. It has two methods in there, index and show. They're both public methods. What Jets does is it takes those public methods and it transforms them to, guess what? Lambda functions, right? And now those Lambda functions are kind of, there's helper methods when they're available. There's a render method. You can render JSON if you want to. You can render XML if you want to. You can render HTML if you need to, all right? There's also, in that show method, there's a params kind of helper method that kind of parses out the event payload that's coming upstream from the Lambda context there, or the Lambda parameter. And that just provides the parameters in an easier kind of format. You also have access to the raw event payload. And when you do a puts in the AWS Lambda world, that saves it out to CloudWatch logs. So you get centralized logging basically kind of built in. Okay, so the next construct is a Jets file, a Jets routes file. So you can see there Jets draw. Might look familiar to some of you guys. There's the get, there's posts, right there is the kind of resource or the path. Then, so the HTTP verb is get, the resource is post, and is pointed to the post controller with the index action. Guess what that routes file gets translated to? It's a good mapping to API gateway resources. Just takes this routes file and translates it to API gateway RESTful resources for you. Finally, there's Jets jobs. So sometimes you have slow requests, and you rule 101 in web development world, if you're working on a site with a decent amount of traffic, is do not block that web request. No matter what in the world, don't block that web request, please. Right? The passengers can queue up, or a unicorn, or whatever you're doing. So sometimes the pattern is you use background jobs and you offload this to a synchronous process. So Jets kind of supports this via this concept called job. And what you do is you declare the rate keyword or cron keyword, and then you express kind of how often you want to run that job periodically. Those expressions, those keywords get translated to CloudWatch event rules. Right? So Jets kind of evaluates this code and translates that rate and cron to a CloudWatch event rule. And then the public methods there are translated to Lambda functions, and those two are kind of glued together. Okay, so let's review the components real quick. So Ruby methods get translated and transformed to Lambda functions. Routes, that routes file gets translated to API gateway resources. Jobs gets translated to schedule event rules. Okay, so there's a Jets new command to get you guys started. So there's 3 different modes of operation here. There's a Jets new demo, which mode HTML, that's the default. This is basically HTML CRUD. There's Jets new with a mode API. This will generate a lighter structure for you, and then you can build kind of APIs with this. And actually one of my favorite modes is job mode, a very, very light structure. Let's say you only need like a Lambda function or 2 to do something where you don't want to spin up a server. There's also a notable no database option if, let's say, you're building API that doesn't require a database. Let's say you're gluing maybe APIs or third-party integrations there. Okay, for the Jets new demo, this is the project structure that's generated. There's the app folder. There's controllers, so that's your traditional controllers, basically traditional MVC there with models and views. For helpers, there's your traditional helpers. JavaScript, what that's all about is that's the Webpacker folder. You put your assets in there, and then Webpacker kind of compiles and uploads things for you. There's the jobs folder. Model is going to be active record, so and then also DynamoDB models. Both are supported within the same application together. Views, your layouts, and your other view files. Config for your kind of environmental configurations and initializers. Let's see, DB for your migrations, public folders for public files, and spec for your specs. When you're using API mode, look, the structure is much lighter. You don't need the JavaScript folder anymore. You don't need the views folder anymore, right? You're usually building like JSON APIs or XML, whatever you're doing. So it's a much lighter structure. But look how light the structure for a job mode is. Extremely light. There's only a config folder and app jobs folder, right? So this is, if you're gluing some stuff together, this is the mode I would recommend. Okay, so now I'm gonna do a live demo with internet conference Wi-Fi here. So wish me luck. Okay, so to do a live demo, I'm gonna hilariously go to Quick Start's documentation page and copy and paste. But I'll explain what's happening here while I do this. So, okay, so Jet's new demo, so I'm just using the default mode. So what Jet's new demo does is it creates a storage structure. So that's what it's doing right now, basically generate all those files. It immediately runs a bundle install. So it's installing all your gem dependencies there. And then it's doing Webpacker install, so that actually takes a little time. That's actually the longest process with this thing. So why don't we kind of start exploring a little bit while Webpacker kind of takes forever there. Okay, let's go to app controllers. We have application controller. We're gonna have models here. So we're gonna have the application record. Okay, our application controller. I'm gonna start kind of reorganizing this a little bit. Let's kind of move this down here. Let that kind of generate. Okay, so that finished generating. Let me organize that. So after that generates, so that's the Webpacker install, and then it spits out some additional instructional information. So I'm literally gonna read my own instructions here. CD demo, and then we'll go Jets generate scaffold title string, just a simple one. So I'm going to generate a scaffold, okay, with a post model. And here there's the post controller that just got generated. Let's move this up here now. So you can see generate index, show, all that. I'm gonna kind of get this started. Environment, and then okay, so I want to copy over that because it contains basically the database URL that's needed to deploy. And now actually I've commenced to deploy. I've started deploying this onto AWS Lambda API Gateway and such. Okay, and that's going to take a couple minutes. So let's go ahead and continue exploring through what was kind of generated here with those 4 commands. Okay, so here's the post controller. There's the kind of the 7 HTTP methods, the actions there. Here is the application record. The post record was the active record inherits from that. So that's pretty traditional there. And then I think it'd be interesting to also look at the routes file. So here's the routes file, and then when I ran basically the scaffold, it injected this resources post. And kind of one way to check that out is you can go cd demo jets routes. So if you run that command, you can see that this resource kind of keyword expands the 7 RESTful routes there. Okay, and then I'm going to go ahead and start a server up here locally. So while that's deploying, we can actually test this thing locally because it's important to probably test your code locally before you deploy. Apparently in the serverless world, sometimes people are just like, how do you test? On AWS Lambda. Local mode is probably useful. So I've already kind of set up kind of DNS record to point to essentially this Cloud9 server, which is essentially like a local server here. And you can go here, so I generate all that, test 5. So this is local, okay? So that's how you test it. And let's go back to here, and the deployment is still kind of going there. So let's see what else. So these are the routes. Here's the view files. Here's the layouts, application, right? And then here's the posts. Very kind of all traditional stuff right here. There's the form. That was all kind of generated. Let's look at some helpers. I'm just kind of exploring here to buying some time. Oh, well, let's actually look at application also. Yeah. So reload. Okay. And then you can see that you can kind of configure things here in your application.rb. You can actually configure things like this is where you actually configure pre-warming. See, it's just a bunch of flags you configure, and then it actually creates some Lambda functions for you to kind of generate the pre-warming, all that kind of stuff. Let's see what else is kind of cool. There's the migrations. Anyway, the deploy is done. So why don't we check it out? And I'm gonna cross my fingers here. But anyway, this is now running an API gateway and AWS Lambda. So with 4 commands, we're able to deploy and translate our Jets application to AWS Lambda. Let's see if the CRUD works. So this is connected now to our RDS database. We'll just go test 5, submit. So it's just traditional CRUD. We'll save it, and then we'll go back. But so this is local, and this is on AWS Lambda. And what Jets basically did was just translate your code to the Lambda Functions API gateway, as I mentioned earlier, after I covered some essentials. So back to the slide deck. That is the demo. All right, so let's review what was covered. So web API architecture review. So we built essentially most of that, except for the schedule event rule. I just didn't do it for the sake of time for presentation, but it's just as easy as copy and paste the coding and deploy it. But we essentially created all those RESTful API gateway endpoints, all those Lambda functions. I did set up the database ahead of time for this, but we did that with literally 4 commands. Okay, and that's what we did. Okay, let's review the Jets components one more time. Remember, Ruby methods, I just want to emphasize, gets translated to Lambda functions. API gateway, the routes file gets translated to API gateway RESTful resources. Jobs will get translated to schedule event rules. Okay, so why Jets again? So I just want to lay out like the Yama code versus Ruby code. Now up there, it's not so bad. 15 lines of code, right? It's not so bad there. But the Ruby code is only 6 lines of code. And if you have, let's say, anything more than an application with 1 function, and that's going to exponentially kind of increase, you're essentially coding YML. There's going to be a lot of duplication. So I don't know. For me, Ruby makes me a lot happier than configuration. And there's a need and purpose for configuration too. But with code, you actually have the full expressive power of code. I could actually dynamically generate those methods if I wanted to. So that's kind of neat. Okay? Okay, now, there's even more to serverless than what I covered so far, right? So there's more. So AWS Lambda, some people call it glue. It's functions as a service. You're using functions to glue together things in the system, right? What type of glue? Lots of glue. All these things are actually supported by Jets. So you could connect a SQS queue. Every single time you add an item to a queue, that could fire off a Lambda function process off the queue. So that essentially creates an auto-scaling queue for you. You connect to S3, and basically every time I upload an image, it resizes the image or do some processing on it. Kinesis, SNS topic, DynamoDB streams. DynamoDB streams are interesting. It's kind of like an active record callback. Whenever you modify an item within DynamoDB, you can fire off a Lambda function, do some processing to it. IoT, which I cover a bit, and CloudWatch event rules, which I kind of covered. So here's a use case. Here's an example of using serverless technologies kind of together. So let's say your company has some kind of standards around what port they should open for SSH access. They don't want port 22 open to the world. They want it open to specific IP addresses. Well, you know, developers and engineers, they're going to try to do whatever they do to fix their code. They're kind of focusing on debugging and fixing bugs. So they might open up port 22. What you can do is actually monitor your AWS account for any changes in your security groups and automatically close up that port continuously. At the same time, you can also notify yourself who opened it. So what does that code look like in Jets? It kind of looks like this. Rule event right above the Lambda function. And guess what that construct is translated to? This YML, which gets translated to the event rule as an AWS resource. Another kind of interesting use case. I have fun time putting together this diagram. So that's Amazon Echo there. There's a car. So you can connect all sorts of things to the internet now. You connect your car to the internet, which I would be concerned. What happens if like you get hacked, right? That'd be kind of scary. You can connect a tea kettle, because for some reason you can send tea kettle data to the internet. I don't know why, but you can. And essentially, you can send a lot of data now to the internet, and you could connect that to a Lambda function, okay? And what does that look like? It looks like this. This is a thermostat job. It's collecting temperature readings and sending it to the cloud. And this Lambda function now is gonna it's do a put statement there just for debugging, but you could do logic in there, right? And what does that get translated to? Is YML that gets translated to the IoT resource on AWS. Okay, here's another use case that actually I like a lot. So this is like cron jobs, like simple cron jobs with that job mode that I showed you earlier. So CloudWatch event here is saying, okay, run this Lambda function every single day, and it backs up Route 53 records. So I kind of do this for some companies. When I'm modifying Route 53 records, I'm like afraid I might modify something and not remember what I just changed. So I like to set up a backup and kind of basically this job will read the Route 53, then back up all the records onto S3. So then I have kind of a historical record of all DNS records. What this code looks something like this. You guys have basically decorations above that Lambda function there or that Ruby method, and that gets translated to YML again. Okay, the last use case here, S3 events for image processing. So in this diagram, we have a couple different things going on. We have SNS topic as the middleman before we hit the Lambda function. You could actually connect that Lambda function directly to the S3 bucket to something called S3 bucket configuration. And so it's basically whenever you upload something to S3, it'll fire off a Lambda function. But Jets chose not to do this because you could only register one thing to the bucket. Instead, I chose to register SNS topic to the S3 bucket, and in turn, that fans out to multiple Lambda functions in case you want to connect, maybe do two types of different processing on the same photo that you upload to S3. Okay, so to do all this setup requires this one line of code, S3 event and bucket name. That one line of code will set up the SNS topic, and whatever Lambda functions you have kind of connected to that will wire it for you and generate YML for you. Okay. Okay. So one thing I want to cover is the Jets core resource model. So here you have a job, and you have a rate expression above the method. That rate essentially gets translated or calls resource. This is one key learning point. All paths in Jets lead to resource. Resource is where everything meets. By understanding this kind of key point, you could actually write your own resources and customize Jets with any resource you need. Yeah. So Jets features. There's pre-warming, which I kind of mentioned, just a couple of configuration files. Jets local server, you start with a local server so you could test things locally. Essentially mimics API gateway locally via rack. Jets call, which is just like an easier way to call your Lambda functions or your local functions with a prettier CLI essentially. So it's another way to locally test. There's REPL console, which is like Jets console. It essentially just loads IRB with the Jets environment and your application code so then you can play around with things. So there's local server, Jets call, and REPL to kind of test locally in 3 different ways there. There's database support via active record relationship databases are supported. And there's also DynamoDB support. There's function properties, which I didn't cover here for the sake of time. But function properties are basically things like function timeout, memory footprint, environmental variables. Those things are all configurable both globally and at each individual function via DSL. There's IMA policies also. What IMA policies are they're kind of the way you control permissions to your AWS resources, and that's also controlled via DSL, both globally as well as at the function level. Extensions, essentially you just have to understand how to use the core resource method, but there's extensions supported too. Okay, here's a repo with a bunch of examples. I think most of them should still be working. And there's the doc site there. So I wanted to kind of close with this, the future. So before the AWS invented the cloud, there were data centers, and there still are, and there's still plenty of use cases for data centers, don't get me wrong. But when the cloud came about, a lot of people were like, oh, that's great, the AWS cloud, but I need my data center still. Right? That was kind of the mindset of people back in the day. Nowadays, whether you're a small startup or a large kind of enterprise company, when you start thinking about building an application, the first thing you think about is cloud first. Your mindset has kind of been altered, right? You don't really think data center first. Even Netflix, right? Big customer there, right? Nowadays, with AWS Lambda and serverless technologies out there, people go, oh, AWS Lambda, that's great, but I still need my EC2 server, right? The mindset, I don't think, has completely shifted yet. But I think in time, as limits and constraints will move away from serverless technologies, this mindset might shift a little bit where you don't have to manage that server anymore, right? So that's just my guess there. Okay, the link to the slides are up here, and I'm going to be around in the hallway and here for the rest of the conference for any questions. Okay, that's it. Thank you very much for your time.